I know you're all super excited to start Chapter 5. This year, I wasn't planning to do these by video, but we are staying at home and having our instruction remote, so here we go with another chapter of videos. Woohoo! In Chapter 5, we'll be talking about polynomials. As a start then, because polynomials are going to have a lot of exponents, we have a sort of review introduction section talking about properties of exponents. This should be review, so I'm going to talk through them just in case it's not. I'm not going to spend a long time on them. We're going to talk about the properties of exponents. I'll talk about each one individually, just briefly. But I will spend a little bit longer explaining why you would subtract or add exponents together, because that's what we spend most of our time doing when we're dealing with exponents. Then we're going to do some examples where we use the properties to simplify. That's what you'll be doing in this section. The properties of exponents are listed here. They're also listed in your textbook. So the product of two powers says if you have two powers being multiplied together, if they have the same base, you can combine them into one power by adding the exponents. Power of a power, if you have a power already and it's raised to another power, you just multiply the exponents together. Power of a product says you can distribute a power over a product. This is like the distributive property you've seen before, but this is exponents being distributed over multiplication rather than multiplication over addition. Please don't try to distribute powers over addition. That actually doesn't work. The negative exponent property says if you have a base raised to a negative exponent, you actually need the reciprocal of what you see. So if it's just if the base is just a number and you raise it to a negative exponent, you need to turn it into a fraction and put it on the bottom. If you see a negative exponent that's already on the bottom of a fraction, you should move it to the top of that fraction. The zero exponent just says anything to the 0 power is 1, which applies to any number that's not 0. 0 to the 0 power is a whole mess that we don't need to deal with in high school. The quotient of two powers, if they have the same base, you combine them just like you did with product of powers, except that because you're dividing instead of multiplying, you're going to subtract the exponents instead of adding the exponents. Lastly, you can distribute a power over a fraction, a quotient, just like you did over a product, but only if there's no addition or subtraction involved. So as far as adding and subtracting exponents, we see that here for a product of powers, and we see it here for a quotient of powers. And just to unpack what's going on, all of these properties are based on the understanding of what it actually is to have a number raised to a power. So x to the 5th power, what that really means is x multiplied 5 times. And x cubed, x to the 3rd power, is x multiplied 3 times. So when we're looking at this and we stick them all in together, if we have 5x's multiplied here and 3x's multiplied here, when we put them together, we have a total of 8x's multiplied together. So 5 plus 3. Conversely, if we're dividing the x to the 5th by the x to the 3rd, subtraction tells us the answer is x squared, right? Subtract the exponents. 5 minus 3 is 2. If you look at it, think of it as a fraction, x is multiplied 5 times on top and 3 times on bottom, but you reduce a fraction by canceling common factors. So once all 3 on the bottom have canceled 1 on the top, the 2 left over on top are what's left. The difference between the number of x's is what's left behind. This works if the x to the 5th is on top. It also works if x to the 5th is on the bottom. 3 minus 5 is negative 2, and that negative exponent, as we saw on the previous page, negative exponent means you need the reciprocal, so x to the negative 2 is actually 1 over x squared. Anytime you subtract and get a negative result, that means the power should be on the bottom rather than the top. This works for canceling as well. If there's only 3 on top, then by the time you get done canceling, the 2 x's that are left over are on the bottom, and they should stay there. Just because everything on the top cancels doesn't mean the fraction goes away. You should leave a 1 on top if everything else cancels. The 2 x's here are on the bottom, and they need to stay there. We have 4 examples to talk about. This should be enough to get you used to using these powers. Each one of these you can actually approach a few different ways, so I'll be showing you a couple different ways to solve these. We'll talk through them. The most important part is using the properties of exponents. The order that you use them in is less important. So when I see this first example, w to the 5th times w to the negative 8th times w to the 6th, my instinct is to apply the product of powers. So just add the exponents all together. 5 and -8 and 6 makes a total of 3. You could approach this by dealing with the negative exponent first. W to the -8th suggests that W should go to the bottom. So we can do that first. Then when you multiply the top together, you get 11. The bottom has a power of 8, so 11 minus 8 is 3. End up with the same answer, even though we applied the rule in a different way. That's normal. You should always get the same answer if you use the rules correctly. Our second example here, we have a quotient raised to a power. We can distribute this -2, which my inclination is to do that first. So the c gets raised to the -2nd power, as does the d to the -4th. Power to another power, that's where you multiply the exponents. So -4 times -2 is +8. Because the exponent on the c is now negative, we're going to move it to the bottom next to the d. So we have 1 over c squared d to the 8th. You could approach this problem by dealing with the negative exponents first before you distribute. Because this power is negative, that means you need the reciprocal of the fraction inside. So you could rewrite it so the inside is upside down first, raised to the +2nd power. Then, of course, because this is also a negative exponent, it needs to move to the bottom. Then you can distribute the power, so c becomes c squared, and d to the 4th squared is d to the 8th. Again, two different ways, wind up with the same answer. Our third example, the a's and the b's, those are different bases, so they don't go together. So we're going to focus on combining the a's. Just subtracting tells me well, that's my second example, I guess. The first way I did this was I took the negative exponent and moved it to the bottom, because that's what I did in the previous problem. And then a to the 3rd times a to the 5th is a to the 8th. Now you can't simplify this any further because they don't have the same base, nor do they have the same power. The other way to approach this would be to just subtract. So -3 minus 5, if you subtract the exponents, you'll get -8, which tells you a to the 8th, which goes on the bottom because it was negative, right? -3 minus 5 is -8. So you stick a to the 8th on the bottom rather than on the top. Our last example then is the most involved. The two broad approaches I see here are distributing the power first or simplifying the inside first. I'll start with distributing the power first. It's sort of my go-to, but I will show it to you again where we simplify the inside first. So if you're going to distribute this 3, everything gets raised to the 3rd power. Power to a power is multiply, so the a squared to the 3rd power becomes a to the 6th. b to the -1st to the 3rd, -1 times 3 is -3. It's easy to overlook the 2 because it has no power, but it needs to get cubed as well. A to the 3rd cubed, 3 times 3 is 9, and of course 2 times 3 is 6, so that's b to the 6th. Now the 2 doesn't have anything to combine with, so 2 cubed just is an 8 on the bottom here. But these a's will combine. We're dividing, one's on top and one's on the bottom, so 6 minus 9 is -3, which makes a cubed on the bottom. And then -3 minus 6 is -9, so b to the 9th goes on the bottom. Now here I distributed the power first and then simplified. We can do this problem by simplifying the inside first. So the 2 stays alone. A squared divided by a cubed, you do 2 minus 3 and you get -1, so a to the -1st. -1 minus 2 is -3, it's b. These both have negative exponents, so I need to move them to the bottom. I don't usually write this step. Just if I subtract and get or add and get a negative result, I just move it to the bottom immediately. So a to the 1st on the bottom and b to the 3rd. Now I distribute the power. 2 cubed is 8, a cubed is a cubed, and b to the 3rd cubed is b to the 9th. This should be enough to get you started. Please don't hesitate to ask if you have questions. But I hope you enjoyed the video, I guess. I hope you found it helpful. Good luck.